Hello friends. Friends, today we will discuss and calculate the electric field intensity on equatorial line of electric dipole. Last time we have done the same process for the axial line of electric dipole. Now consider an electric dipole AB. Electric dipole AB. We will find electric field intensity at point P on the equatorial line. Now a line passing through the midpoint of dipole, and perpendicular to the axial line, it is known as equatorial line. Okay, a line passing through the midpoint of dipole and perpendicular to the axial line, it is known as the equatorial line of dipole. And I have already discussed about the what is the meaning of dipole, what are dipoles in my previous lecture. So here OP, we can take OP equals to R. Okay, so we will, if E1 is the electric intensity at P due to charge minus Q at A. E1 is the electric intensity at P due to charge minus Q at A, then E1 equals to 1 by 4 pi epsilon naught Q upon AP square. Now the direction is towards the minus charge, because due to negative charges the direction of the lines of forces are always inwards. Okay, so E1 equals to 1 by 4 pi epsilon naught Q upon AP square, but AP square equals to OP square plus OA square. If we take this triangle, then AP square equals to OP square plus OA square. Now what is OP? OP is equals to R. So OP square is R square and OA is half of AB. So it is A. So it will be A square. Therefore E1 equals to 1 by 4 pi epsilon naught Q upon R square by plus A square. Equation number 1 along PC. Now why? This is the direction of PC. Okay, due to this reason. Now let angle PBA. Let angle PBA is theta. Therefore E1 has two rectangular components. E1 cos theta along PR. E1 cos theta along PR, and BA, PR and BA, because these are parallel lines, and E1 sin theta along PE, E1 sin theta along PE. I hope so you remember how to make the rectangular components. Now let us again revise it. Okay, suppose this is electric field intensity and it is making angle theta here. Okay, and if I draw a line here perpendicular to here, now suppose this is B, this is O. Now suppose if we take cos theta. Now what is cos theta? Cos theta is base upon hypotenuse. Now what is base? Base is OB and hypotenuse is OE. Then this component OB equals to OE cos of theta. OE cos of theta. And this component, suppose this is C. Okay, this will become, or we can calculate from sin theta. Now sin theta is BE upon OE. So B is equals to OE sin of theta. Okay, so this will be the sine component. Okay, this is the method to calculate the rectangular components, and the shortest method is the side which is having the angle coinciding, that is always the cos component, and other side is the sine component. Okay, so we will have two components, E1 cos theta along PR and BA, E1 sin theta along PE. Now if E2 is intensity at P due to charge plus Q, due to charge plus Q at B, then E2 is equals to 1 by 4 pi epsilon naught Q upon Bp square. Now as Bp square equals to, you can see from here, OP square plus OB square. Bp square equals to OP square plus OB square. So Bp square equals to R square plus A square, and E2 will be 1 by 4 pi epsilon naught Q upon R square plus A square, equation number 2. Now as E2 is represented by PD and has two rectangular components, E2 cos theta along PR and BA, E2 is represented by which component? Along PD, and has two rectangular components. One component is E2 cos theta along PR, along this direction by this rule, and BA, and E2 sin theta along PF, along PF, that is opposite to PE, PF along opposite to PE. Therefore sin theta components cancel out, sin theta components cancel out. From equation 1 and 2, it means कि E1 equals to E2. From equations 1 and 2, you can see this is equation number 2 and this is equation number 1. Okay, both are same. Therefore, resultant electric field intensity at P is given by E is equals to E1 cos theta plus E2 cos theta, because both the components of cos theta are along this direction. Sin theta components, one component due to this is along this direction, and another component due to minus charge is along this direction. They will cancel out. Okay, so E1 cos theta plus E2 cos theta, and because E1 equals to E2, it will become 2E1 cos theta. If we put the value of E1 in this equation from equation 1, it will become 2 upon 4 pi epsilon naught Q by R square plus A square cos theta equals to 2 by 4 pi epsilon naught Q by R square plus A square. Now what is cos theta? Cos theta is OB by BP. And what is OB? OB is A. And what is BP? Root of R square plus A square. If we put the value of OB and BP here, so E is equals to 2 by 4 pi epsilon naught Q upon R square plus A square, A upon root of R square plus A square. So denominator will become R square plus A square raised to power 3 by 2. So this is the electric field intensity due to equatorial line of dipole. Q into 2A, we can put the value P, because dipole moment equals to Q multiplied by 2A. The direction will be along PR, remember from the diagram. Now case if dipole is short, 2A is very lesser than R, then E is equals to P upon 4 pi epsilon naught R square 3 by 2, because we can neglect A square comparative to R. So cancel out P upon 4 pi epsilon naught R cube, and here again R is inversely proportional to cube. R is inversely proportional to R cube. If we will discuss the special case, if dipole is short, 2A is very lesser than R, then we can neglect A square comparative to R square. Okay, from this equation. Okay, so we will have then P upon 4 pi epsilon naught R square 3 by 2, 2 and 2 cancel out. It will become E is equals to 4 pi epsilon naught R cube. It means E is inversely proportional to R cube. It means for the equatorial line, electric field is inversely proportional to R cube. Same is the case with the axial line case. Okay, so dear friends, this is all about the calculation of electric field intensity due to equatorial line of dipole. I hope you have understood. If there is any doubt, please share in the comment section. Thank you. Thanks a lot.